Good morning, students. In this video today I'll discuss about sulfuric acid. Sulfuric acid is H2SO4. It is a covalent compound. It is also known as king of chemical because there is no other manufactured compound which is used by such a large number of key industries. Another name of sulfuric acid is oil of vitriol. It is also known as oil of vitriol. Sulfuric acid is also known as oil of vitriol. In the later Middle Ages, it was obtained by oily viscous liquid by heating crystal of green vitriol. It is obtained by heating. It was obtained by heating crystal of green vitriol, and therefore it is also known as oil of vitriol. Sulfuric acid is also known as oil of vitriol because it was it was obtained by heating crystal of green vitriol FeSO4.7H2. This is the formula of green vitriol. Okay. Now see preparation or manufacture of sulfuric acid. The method is known as contact process. Manufacture of sulfuric acid H2SO4. Only chemical reactions you have to read and conditions. Details procedure not required according to the syllabus. This method is known as contact process of preparation of sulfuric acid. So in this contact process, first step, production of sulfur dioxide. In the first step, sulfur dioxide is produced by roasting metallic sulfide like iron sulfide in air. So in first step, sulfur dioxide is produced from iron pyrites. In this step, metallic sulfides are heated with oxygen, that is roasting of metallic sulfide, that is roasting of iron sulfide Fe4FeS2 plus 11O2 implies 2Fe2O3 plus 8SO2. So in the first step of contact process, it is the production of sulfur dioxide. You can also produce sulfur dioxide by heating sulfur, that is S plus O2 implies SO2. Okay, so sulfur dioxide is obtained by heating iron pyrites or by burning Louisiana sulfur in purified air. So after obtaining sulfur dioxide, second step is purification of gases. The mixture of sulfur dioxide and air contains various impurities which must be removed, otherwise the catalyst loses its efficiency. In second step, after purification, in next step, the next step is catalytic oxidation of sulfur dioxide. Catalytic oxidation of sulfur dioxide. In first step, sulfur dioxide is produced from iron sulfide or iron pyrites or from sulfur by burning. In second step, purification of gases. Third step is catalytic oxidation of sulfur dioxide. In third step, sulfur dioxide reacts with oxygen in presence of vanadium pentoxide catalyst to give sulfur trioxide, and the temperature required for this step is 450 degrees Celsius. Only chemical equations and conditions you have to remember. Details description not required. Okay, so in third step, it is catalytic oxidation of sulfur dioxide SO2 plus O2 in presence of catalyst V2O5. Temperature is temperature required 450 degrees Celsius to give SO3. So 2SO2 plus O2, reversible arrow, 2SO3. This is the chemical equation. After formation of sulfur trioxide, in next step, absorption. Next step is absorption of sulfur trioxide in sulfuric acid. In absorption tower. Absorption of sulfur trioxide in sulfuric acid to form oleum. So sulfur dioxide sulfur trioxide gas is cooled in a heat exchanger and then absorbed in absorption tower in concentrated sulfuric acid, 98% sulfuric acid, to form oleum. So SO3 plus H2SO4. SO3 absorption of sulfur trioxide in H2SO4. SO3 plus H2SO4 implies H2S2O7. This is also known as oleum. In last step, dilution of oleum. Dilution of oleum to obtain sulfuric acid. Okay, so in last step you have to dissolve the oleum produced into water and sulfuric acid will be produced. So the last step is H2SO7 plus H2O implies H2SO4. Here one note is given: since sulfur trioxide gas does not dissolve in water satisfactorily and it gives a lot of heat and forms mist droplets of sulfuric acid, it is not directly absorbed by water. The question is, why sulfur trioxide not directly dissolve in water? Because sulfur trioxide gas uh, sulfur trioxide gas does not dissolve in water satisfactorily and it gives a lot of heat and forms mist droplets of sulfuric acid. So these are the steps of contact process of preparation of sulfuric acid, H2SO4. So all chemical equation conditions you have to remember. Okay, some favorable conditions for the conversion of sulfur dioxide to sulfur trioxide. So favorable conditions for the conversion of sulfur dioxide to sulfur trioxide. These conditions you have to read. Favorable conditions for the conversion of sulfur dioxide to sulfur trioxide contact process. Exothermic reactions are favored at low temperature. The temperature should be as low as possible and temperature is required. The yield has been found to be maximum at temperature 410 to 450 degrees Celsius. In this reaction, suitable catalyst, vanadium pentoxide catalyst is used. Platinum is more efficient as catalyst than vanadium pentoxide, but platinum is more expensive and it is also easily get poisoned by impurities like arsenic 3 oxide. So vanadium pentoxide is used as catalyst. So see the summary of contact process. All this reaction with conditions you have to remember. Okay. Now see properties of sulfuric acid. Physical properties not required. Chemical properties. Acid properties. Sulfuric acid is acidic in nature. So it reacts with active metal, it produces hydrogen gas and metal sulfate solution. Okay, so sulfuric acid reacts with active metals to form metal sulfate and hydrogen gas. This is the acidic property of sulfuric acid. So when sulfuric acid reacts with metal carbonate, dilute sulfuric acid reacts with metal carbonate, it forms carbon dioxide, salt and water. Salt, water, carbon dioxide. When sodium carbonate is reacts with sulfuric acid, it forms sodium sulfate, water and carbon dioxide. Okay. When metal sulfide reacts with sulfuric acid, it forms metal sulfate and hydrogen sulfide gas. Okay, hydrogen sulfide gas, salt and hydrogen sulfide gas will obtain when metal sulfide react with sulfuric acid. Properties of concentrated sulfuric acid, non-volatile nature of concentrated sulfuric acid. Concentrated sulfuric acid is a non-volatile acid and it is used in preparation of many volatile acid like NaCl, like HCl, HNO3. Okay, so when salt of volatile acid like NaCl, KCl are treated with concentrated sulfuric acid salt like NaHSO4, KHSO4 obtain, and volatile acid obtain. Okay, so in the preparation of volatile acid from non-volatile acid H2SO4, sulfuric acid is used. Sulfuric acid is a non-volatile acid. When it reacts with salt of volatile acid salt is produced and volatile acid is produced. Okay. Oxidizing character of sulfuric acid. Sulfuric acid is a strong oxidizing agent. It reacts with non-metals like carbon, sulfur, and it oxidizes the non-metals like carbon to carbon dioxide, sulfur to sulfur dioxide. Okay, so reaction between carbon and sulfuric acid, C plus H2SO4 implies CO2 plus water plus SO2. S plus H2SO4 implies SO2 plus H2O. Okay, this reaction you have to read according to the syllabus. Dehydrating agent, sulfuric acid acts as a dehydrating agent. Huh. Dehydrating agent, action on glucose, cane sugar. So all carbohydrates such as glucose, sugar, cellulose react immediately to give a black spongy mass and carbon dioxide which rises up. So reactions are given C6 H12O6, concentrated H2SO4, arrow 6C plus 6H2, reaction of glucose, reaction uh, between glucose and carbon concentrated H2SO4 to give 6C plus H2, reaction of cane sugar, that is C6H12O6, and sulfuric acid to give 12C plus 11H2, sugar charcoal. Reaction of concentrated sulfuric acid with hydrated copper sulfate, that is blue vitriol. Hydrated copper sulfate becomes dirty white because the 5 water molecule removed from copper sulfate. So these are dehydrating action of concentrated sulfuric acid. Concentrated sulfuric acid can also act as dehydrating agent. Okay, and use of sulfuric acid not required. And the last is chemical identification test of sulfuric acid. When sulfuric acid is passed through when potassium dichromate, acidified potassium dichromate reacts with sulfur dioxide, green colored chromium sulfate is obtained. Using this reaction, you can identify sulfuric acid. Okay, so concentrated sulfuric acid on heating with copper evolves sulfur dioxide. This sulfur dioxide, when reacts with acidified potassium dichromate solution becomes green. Orange color potassium dichromate solution becomes green. Okay, so this is an identification test for sulfuric acid. Okay, sir. Thank you.